the name of carbohydrate D-glucose. In the D-glucose name, what is D is the question. It is not given small d, it is given capital D. We all people know that when we talk about a small d or plus, small l or minus, these indicates us optical rotation. We know that D indicates a dextrorotatory substance, the substance that rotate plane polarized light to the right, and this L indicates a levorotatory substance, the substance that rotates plane polarized light to the left. So optical rotation it speaks about, but when it comes to capital D and capital L, we talk here about the absolute configuration. It's capital D and capital L. They speaks about absolute configuration. So what do you mean by that? Let's check it. Students, let me tell you that the capital D and capital L configurations, they depend upon the plus glyceraldehyde and minus glyceraldehyde. Let's write plus glyceraldehyde structure. So you know this is aldehyde, the derivative of glycerol. You know glycerol is a triol. We have a OH. We have OH. 1, 2, 3 and 1 is the 4. 1, 2 and 2 is the 4. You look at the chiral carbon configuration. This is plus glyceraldehyde structure. Let me show you how does minus glyceraldehyde looks like. Only you change the configuration of chiral carbon configuration. So from OH to the right you take it to the left, and from left H you bring it to the right. So everything else you just write them as it is. Only right left of the chiral carbon configuration you are changing. This is minus glyceraldehyde. Capital D and capital L, it depends upon this and that. Okay. Now let me write the structure of glucose. You know that glucose is an hexose. Hexose means total 6 carbon must be there. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. I know it's aldohexose. At the terminal position there is aldehyde. I know that glue indicate the 3 last OH at the same side, that's the right side. So I am writing glucose, a glue is a gum, 3-letter glue indicate that the last 3 OH at the same side, that's the right side. The remaining OH I am showing at alternative side. So 1, 2, 3 and 1, 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 1, 2 and 2 is a 4. So this is glucose. How I said it is D-glucose. Let me check. Look at the chiral carbon that is at a farthest distance from the functional group. If you look at this configuration, it resembles the chiral carbon configuration of the plus glyceraldehyde. So absolute configuration I must give is capital D. Fine. Now if you talk about the fructose, again fructose is hexose. Everyone write hexose. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Let me show you ketohexose. The position 2 is ketonyl carbon. Then everything as it is like the glucose structural formula writing technique that we used. You know that the glue indicate the gum, 3-letter glue indicates that the last 3 OH on our same side, that's the right side. Remaining carbons I am showing OH on our alternative side. So 1, 2 and 2. 1, 2, 3 and 1, 1, 2, 3 and 1, 1, 2, 3 and 1, 1, 2 and 2 is the 4. Now you look at the chiral carbon that is at the farthest distance from the functional group. Again, this chiral carbon configuration resembles the chiral carbon configuration of the plus glyceraldehyde. So we call even it as the D-fructose. So students, the capital D, capital L, it does not depend upon every chiral carbon configuration. It only depends upon a particular chiral carbon configuration, and absolutely I can see that particular statement is given at option D. So we must tick option D here as the answer.